friends, welcome to Science with me. My name is Dr. Erica with Rosie Research, and we are making a fun police car using our breadboarding skills that we've been working on and our programming skills using Arduino Uno. And if you're a patron of ours, you probably have the Elegoo kit, and we will be able to make all of these things mostly with the Elegoo kit, which is going to be a lot of fun. And one of our patrons thought it would be fun to be able to control when this was on and off, because we could plug in a 9-volt battery right here on the Arduino Uno, and then this little guy could actually move around without being plugged in. And I thought that was a great idea. So in this lesson, we are going to add an IR remote to our project. So you can come up to search, and we can search for just IR, should look for what we want, but maybe IR remote. There we go. And we are going to bring this IR remote out. And the idea is that I can maybe turn it on and off, and we'll do that in this lesson, and then maybe in another lesson we can turn it right and left using certain buttons of this IR remote that comes in your Elegoo kit, which will be a lot of fun. Now we need something for this IR remote, something to receive this IR remote in our breadboard. So we should be able to find the IR sensor. This also comes in your Elegoo kit. It's sort of wired up a little bit different. It doesn't look quite like this, but we will show you that in a different video on how to wire it up on an actual breadboard. So now we have our receiving part of the IR remote, and we have the IR remote, which is going to give. So we're going to push buttons here, receive it here, and then talk to the Arduino as we go. Now if we look at this IR receiver, there are 3 pins. One says output, the other says ground, and the last one says power. And we are going to just hook the ground to ground and the power to power to get this part started. I'm going to color my grounds black. My power, of course, will be red. Just like that. And so now this guy's sort of started up, and we need to plug this in to our Arduino. And we can do that. We can just sort of bring it straight over and put it into pin 6. And I will color that orange just because I don't have any oranges going on already. Now that is all we need to do in terms of wiring. Everything else is going to get done in our code. I'm going to move this guy over here and we'll hit our code. Now we have always been doing this blocky programming, which I love of Tinkercad, but unfortunately for this next part we're not going to be able to do that. So if we look in our inputs, it doesn't allow us to read something specifically from an IR remote. In here, we could read if something was high or low, but this little piece here doesn't necessarily give a high or low into the Arduino. It will actually send a code into the Arduino, and that code will be in the form of a bunch of numbers, and that makes it a little bit more difficult because that's not, a number is not a high or a low. And so we can't use some of these reading situations that we have done before. So what we're going to do instead is we are going to switch to text. So if you come up to that blocks, we've always done the blocks and text where we sort of come over here to copy and paste our code into the Arduino IDE when we're all ready. And I always caution you about going straight to text, and that is because we don't want to lose the ability to use the blocky programming, but this time we actually need to. So we can't program this IR remote without straight text code. So you're going to hit continue on this, and your text is going to look just like this. And I'm going to walk you through the different parts that we need to add to this code to make it be able to talk and listen to this IR remote. So the first thing we need to add is what's called a library. Our Arduino has a bunch of brains, but if we want to teach it to use something new, like this IR remote, we need to give it a book to teach about it. And the way we give it a book is we say include, so pound include, and then whatever book you want to include. And we want to include something called, I think it's IR remote, so capital IR and then lowercase REMOTE, and it's a .h to signify that it is a book to read. Don't forget these little pieces right here on the IR remote, these little sort of greater than less than signs that bracket it. That is going to be a really important part of it. The next thing we're going to tell it is where it's going to receive the IR stuff. So that's in pin 6 here. And 6 is an integer, and the way we talk about integers in programming is int. So you have int space, and then we'll call this the receiving pin. We'll do it RECV underscore PIN in all caps, and that's sort of the industry standard. And we always like to keep it the industry standard when we are programming on our own. So that's going to equal pin 6, and then you're going to put a semicolon at the end. These semicolons are going to be really, really important in our coding as we type our code out. Those guys will really be getting you. All right, and so now we're going to tell the program that we are going to receive on that pin. So IR receive, and this is a part of the program that's in this book. So if you just write this without including this library book, our Arduino isn't going to know what to do. So it's really important that we have that. And the code is IR receive, and then it's going to be receiving on the receiving pin, just like we did before. And don't forget that semicolon, super important semicolon. Once we receive it, we want to figure out what numbers came in. And for the Arduino, that means decoding the results. So we're going to decode the results. And so some of this, if you program, the people who are writing these programs are trying to make it really simple for you to be able, like really understandable to write this. It takes a long time to learn everything you want, but once you get it, it makes it a little bit better. And whatever those results are going to be, we're going to put it into a variable called results. That will be easy for us to remember. All right. I also, in my setup, you'll notice that we said all of these different things before when the Arduino was talking to our motors or our piezos or our lights. These were all output pins that were going in there. We are going to add a new pin. So it's going to be pin mode, just like the other ones. And you're going to say what pin it is. We're in pin 6. And here we're not outputting a signal. We're actually inputting a signal. So instead of output, we'll put input, because we want the Arduino Uno to be looking for a signal in that channel. Now, as we do this, these guys can sometimes give you different codes. So these results might vary for the specific type of little remote that you have. And it might be a little frustrating just to guess the number. And what you can do instead is we can have the number come up in this serial monitor. And if it's attached to your computer, you'll also have a serial monitor in your Arduino IDE so that you can press buttons at your IR receiver and you'll get little numbers here, but we need to tell it to print that. So what we're going to do is we will first tell it to start up, and that's called serial.begin. And you tell it what's called the baud rate, and that's going to be 9600. Keep that semicolon on the end. And then if we want to make sure that we know things are working, we could say serial.print, and let's say we want to know that that IR is enabled. So we could say enable IR, or enabling the IR, enabling, IR. And that goes in quotes, and then the parentheses are closing. So you have these open parentheses, normal ones. Whatever you want it to print inside the serial monitor is within quotes, and then we have that semicolon at the end. All right, and then we are going to enable our IR pin. All right, so we are going to do IR receive, and we will enable, which it means to turn it on, the IR, and then it's going to be going in just like that. All right, and once that's done, we could print that the IR has been, like, the IR in is working. So maybe we serial.print enabled. And then if something goes wrong, we'll know where to start looking depending on what shows up in our serial monitor. All right, so right now in our loop, we write our motors high. And then we do this sort of flashing. These are our lights that are flashing. This is our buzzer that waits for a certain amount of time before it switches its frequency and switches the flashing. But this whole time we have 5 on high, and we're not going to want to do that anymore, right? Because we want to be able to control what is going to be, when it's going to be on with this guy. So we're going to delete that line. And just to keep this all nice and clean, I'm going to come down here and give myself some space for this part of the program. So the first thing we're going to look for is if we receive some sort of IR signal. So if, and then you'll have an open parentheses, and what you put in these parentheses is going to be if whatever you want to happen actually happened. So IR receive, if IR receive dot decode has results like that, then, so here's my if I get results, is basically what this line is saying, then I'm going to do something, and I'm going to do something whatever is in these squiggly lines. Now these squiggly lines are really important, these curly brackets. You always want to make sure you have an open and a closed, and the way that I do that when I program is, you'll notice I don't even have a program in here, but I've already made my open and closed curly brackets, and that makes it easier for me to not lose where I'm at. So if I receive something, the first thing we want to do is print it to our serial monitor so that we can see what number I pressed. All right, and so the way we can do that is we can make it an integer that can change really easily. So that's called an unsigned int, and we'll call that our value. And that value is going to equal our results dot the value of those results. All right, so this is a thing that's going to come in from that library book. I'm going to add an extra space here so it looks nice. And then I'm going to serial print whatever that value is. So I'm going to serial.print, and I'm going to serial print that value. And because it's not something in quotes, it won't write the word value. It will write the whatever number is in this value. If I put the quotes of value, if I put it like this where I have quotes, instead of giving me the actual number that the Arduino sees, it will just give me the word value. All right, that's the difference between those two. And then let's not forget our semicolon at the end. Now the way that we can do something with our numbers that this guy sends to the Arduino is called a case, and you can give it different things to do based on the case, and each case has its own number that's associated to every single button that we have here. So let's say we receive something, if we receive something, and it's also a certain case. We're going to just guess case 255 because we're going for the power button here, but we might find that that's different. Here, instead of a semicolon, it's actually going to be a regular colon. And if it's going to be that, we are going to want to, let's say, digital write, pin 5 high, right? So pin 5 is what we're going to write. We're going to write that high. Now that, I'm kind of assuming is going to be my power button, but I would kind of like my power button to turn it on, and if it's already on, to turn it off. And one clever way we could do that is actually before we come in here, we could say that I is equal to -1 times itself. All right, and so it's always, I is just gonna flip-flop every time I hit this button. It's either gonna be I or -I, and if it was -I, it will become I. If it was I, it'll become -I, and it'll sort of flip-flop. So we could look at, is I positive or negative, and we can have it do something different. We're gonna run into a problem though, because right now the Arduino has no idea what I is. It's like, what? This is a new variable, you haven't told me anything about it. So what we can do is we can come up here above the void setup. So above that void setup, you can give yourself an enter, and you can just say int I, and we could even say that maybe it starts off at 1. All right, and that tells the computer, or Arduino, that I is an integer and it equals 1. So when it comes down here, then it's going to say, oh, I is going to be 1, so we're going to have 1 equals, or I equals -1 times 1. All right, and instead of always writing this high, we're going to write some cases here. And that is if, so let's come down here, we're going to say if, and if I is greater than 0. All right, so that's my condition. And then I'm going to have my open and closed brackets like that, because I always like to write them in there. So if I is greater than 0, let's write this high. So let's cut this and paste it in there. All right, but if it is going to be less than 1, so if I is less than 0, then, so let's do our open and close curly brackets, then I want to write this to low. So I'm going to copy this and paste it right here. And I'll switch this high to low. All right, so we're pretty set up here, although I'm realizing we need to check our switch value, and that goes above our cases. So we're gonna switch and then value, and that will go open. So we'll need another curly squiggly. So this is sort of checking all the different cases that we have here. And then once we've done that, once we've checked the values and we've done what we want to do with that, we also want our IR guy to start receiving again. So we have to tell it to do that, and that is with IR receive dot resume. And that's sort of an open close of regular parentheses and then this semicolon. All right, so we've done a lot of code, and what we'll do is we'll start our simulation and see if we missed anything with our code. If you do, that's totally okay. I probably did, maybe I didn't, who knows? We will debug it together. So here we go, we're starting our simulation, and something says it's not happy, and it says in void loop, we have this error, it says switch is not defined. So let's check that one out. So when I come up here, I spelled switch wrong. So let's change that, S-W-I-T-C-H. There we go, and you notice that before, when I didn't notice that and I had the T and the I mixed, it's black. And then when I switch those back, so it's spelled correctly, it turns purple. And that's what you want. So these purple ones are sort of code words that the computer knows. So let's try starting that simulation again. And now it's saying, oh, function vector 7. So this is a funny thing with Arduino Unos, and that is that it can't do IR and tone buzzers at the same time. So we're gonna have to choose, I hadn't thought about this, we're gonna have to choose between having the siren on our car or having remote control on our motors. So if you wanted the siren on your car, you're actually already set up from our previous video, and what we'll do then is we'll actually just delete this, and we will delete the stuff going into pin 4 so we don't get confused later. And we'll take out pin 4 up here as output. And the big part that's really going to fix this is this tone. For some reason, they use the same things in their libraries. It's a known thing with Arduinos. It's sort of silly, but that should fix it for us, just choosing if you're going to do the IR remote or if you're going to do the buzzer. And let's see if that fixes it for us. It's thinking. All right, so we have started our simulation. We notice that it's enabling, the IR got enabled, and we can come over here. Let's see if we can get this little guy to come over. Let's actually stop this and move this over closer. There we go, and now we can look at our code at the same time. So it enabled again, and now we can press a number, although I don't see my numbers coming up, so let's take a look at that. So, after a little bit of looking, I am realizing that I sort of assumed that my ground and my power to this little IR guy were working. And I do have ground here, so you can see that it comes out of ground on our Arduino. We jumped it all the way down here, but there's nothing else in this line right here, and we need to connect that to 5 volts. So let's stop our simulation, and we will connect this into our power rail at 5 volts. Just like that. And then we'll color that red for later. And we can look at our simulation. Let's start it up again. And let's see if that fixes it for us. And it doesn't look like it does. Oh, nope, it's doing it. So we turned it on and then we turned it off. Now this is not super useful. We're getting these really long lines of stuff. So what we can do is if you stop your simulation, we can change the code. And to get a new line each time, instead of serial print, you just serial print the line, which is serial print LN. So let's add an LN here. And also in this value line, that means each value will get its own new spot. All right, so now let's try this. And we are enabled and we can hit this guy, and it does say 255. let's see. There we go. And it says 250. So this power button is 255. And when I turn it one way and hit it once, it turns on. When I hit it again, it turns off. There is some delay. And part of that is probably the simulation time that it takes for Tinkercad to figure this out. And then in another video, what we can do is learn the different codes. We're all set up so that we can learn sort of right and left, and maybe we could have it pause and do some other things. There's all these things we could do for cases to sort of make up for the fact that we had to lose that piezo buzzer because the tone libraries sort of and the IR libraries they don't like to talk to each other as much. But this is a really fun project. I think we can still build this on that Arduino shield instead of a separate piece, which would allow your car to be the size of an Arduino. And that would be pretty amazing. You could have a little remote control on-off car right now. And we can also look at turning right and left, because you'll notice down here when I hit those buttons, they do, or they should, have different codes. And we'll have to find something that does have different codes so that we can differentiate between right and left. Thank you guys so much for joining me on this project. It's a lot of fun. We've just stepped into typing some C++ code instead of just blocking, and I know that's really tricky. For our patrons who support us at patreon.com/RosieResearch, we will make sure that you have this code in one of our posts. And if we need to 3D print any fun parts for this police car, we will also make sure that we can ship that to you guys, because that is a lot of fun and a great extra. All right, we will see you soon, friends, and have a great one.